So last part of section 4.1, we're going to look at, it's on right triangle trig. And the goal in this part is to solve triangles. That's what it means to solve a triangle. Figure out how big every side is and how big every angle is. Now, there's one thing that you're going to know in every problem no matter what, because of the kind of triangles we're working with. What do you always know is in every problem we're doing in this section all week. Yeah. Right. So that's out of the 6 things, the 3 sides and the 3 angles. You already know one of the sides, or one of the angles, is 90 degrees. Okay.
Well, it just means you know all the angles.
Well, you only know one of them is 90. The other ones could be like 10 and 80, or 45 and 45. So you don't know all the angles, but you're going to know at least one of them right off the bat. So what's left now is 3 sides and 2 angles to find. I can't give you a problem like this and just say solve. I got to tell you more. Right? So in addition to having a 90-degree angle, I'm either going to give you one more side and one other angle, or I'll give you 2 of the sides. Either one of those cases, you have enough information to finish off the problem. Now, I would never give you the last 2 angles. Why not? Why couldn't I just give you a triangle, say this is 90, tell you this and tell you this, and say find the sides? Yeah.
So like one side for reference would be in size.
Yeah. If I just said to you, think of like an equilateral triangle. I know we're not doing, that doesn't have a 90, but it's the same concept. If I said all the angles are 60, tell me how big each side is. You don't know. It could be 2, 2, 2. It could be 10, 10, 10. You have to have at least one side for reference. Okay, so the 2 things we're going to do to solve these problems is first, we're going to make a table. Second, we'll make a sketch. After a while, like for me, I don't really need the sketch because if you tell me like A is this, B is this, and alpha is that, I can just kind of visualize it in my head and figure out, okay, that's opposite, that's adjacent. But at first, it can be hard to do that. So we'll make a sketch so you can see, okay, that's across, that's next to it. And then we're going to put all the information in the table. So the table is going to look something like this. ABC and alpha, beta. And you don't have to fill in anything there because that's just the right angle. That's always 90. And I'll fill in everything that they give me, and I'll put a box or I'll circle what I need to find so then I remember to do it. So things you can keep in mind, Pythagorean Theorem, you can use that. We can use the fact all the angles in a triangle add up to how much? 180. And we can use the 6 definitions I taught you yesterday. That's all you're going to need. In fact, you're not even going to need all 6. You're only going to use the first 3, sine, cosine, and tangent. And the reason why we're going to use the first 3 is because you have buttons for those on the calculator. You don't need to use secant, cosecant, or cotangent for anything in this problems today. So we won't talk about those at all. All right. So as far as notes and kind of explaining what you need to do, that's pretty much it. So we'll do 2 or 3 examples, and then we'll do a word problem, and then that'll be the section. Okay. So solve the triangle. This is the first case. So I said to you there's really 2 cases. I'll give you a side and an angle, or I'll give you 2 sides. Well, I'm telling you a side and an angle. All right. So what's the first thing that I suggested? Well, there's two things, but what's one of the two things I suggested that you do with that information? Yeah. Yeah, just put it in a table. There's your table. So I put the three sides on the left, A, B, C, and I filled in B because they told me it was 2. I put a box around A and C because I need to find those. Next, I put the three angles on the right. That one's always a 90. You don't even need to think about that one this week. They told me alpha was 40, so I filled that in as well. And then I put a box around beta. So where you see the 3 boxes, that's what you need to find. Now, with these kind of problems, you can do anything you want in any order you want. Okay? But I think there's something there that's easiest to find first. Anyone think they know which one there is the easiest thing to find, and you really don't even need anything that I taught you. Stuff you could just use from geometry.
Beta.
Beta. Yeah, how would you get beta?
You just add 90 and the 2 angles that you have and subtract 180.
Yep. So they all have to add up to 180, which means beta would be how much?
It would be 50.
50. Okay. So there's one out of the 3 things we need. That's beta. Any question on how we got that? Okay. Now, what's the other thing that I suggested you do in a problem like this besides the table?
Right.
Yep, we're going to draw it. So that way you can see what's opposite, what's adjacent, and what's hypotenuse. Because you need to figure out what sides you have. I know you have B, but what is B? Is B opposite? Is it adjacent? Or is it hypotenuse? Right? We got to figure that out because that's going to change what trig function we use next. Sine, cosine, or tangent. So let's make a sketch. It doesn't matter how you draw your triangle. You can flip that around, you can rotate it. You just have to make sure that, can somebody tell me one thing that has to be across from another thing? This has to be across from that. Okay. Yes. We always put C across from 90. What else? Yep. 2 across from 50. Yes. B always has to go across from beta. And Hendrik, what's the last thing?
It has to go involved.
Yep. So A has to go across from, what's that letter? Alpha. Perfect. A has to go across from alpha. As long as you do what I just said there, you're fine. Okay, so there's your diagram. Now, what I always do is I just circle the 2 things I was given. You're going to use those 2 things to pretty much do everything else. And now I'm going to circle what I want to find. I want to find A and C. I'm going to do one at a time. So every time you're going to solve for something in a triangle, it's going to involve 3 things. Usually 2 things that you know and 1 thing that you don't. Now, technically I know beta. And that is something I could have used, but I stayed away from it and I stuck with alpha. Why do you think I'm staying away from beta? Yep.
There's less chances that you mess up something.
Why?
Because then you go off the information that you know is right.
Right. We're going off what we know was right, what was given. If you use beta and it's wrong, it's going to make everything wrong. Right? So the way we're going to do these problems is you're never going to use something that you found to find something else. Which means if you do it that way, you could make a mistake on beta, but you could still get A right, and you could still get C right. So you could get partial credit. So again, don't use something you find to find something else. Okay? Always stick with what was given. All right, so let's label these 2 sides from the perspective of the 40. what is side A? Is it opposite, adjacent, or hypotenuse? About Anthony.
Side?
What's side A?
Oh, opposite.
Yep, perfect. That's opposite. And what about side that's 2? That's adjacent. I'm just labeling everything. And C is the hypotenuse. Okay. So we don't need C right now. We're not using C yet. We're gonna look at A. Okay. So I want to find A. To find A, first thing we have to do is figure out which trig function to use. A is the opposite. 2 is the adjacent. There's only one trig function that has opposite, which is the side I want to know, and adjacent, which is the side I already do know. Which trig function has opposite and adjacent? Yeah. Good. Tangent. So we're going to use tangent. And it's always tangent of your angle. What's our angle that we're using? It's circled right there. Tangent of 40 degrees equals. And Nick, what did we say the definition of tangent is?
Opposite over adjacent.
Yep, good. Opposite over adjacent. Opposite over adjacent. A over 2. And the last step is just to get A by itself. So Kyle, what would I do on both sides to get A by itself? Yeah, perfect. Multiply by 2. Times 2. Times 2. And there's your answer. We're going to type that in and just round it off. But that's how you get A by itself. Okay. Any question on that? When I type that in on my calculator, what do I want to make sure of? Especially if you look at my calculator. I want to make sure I'm in degrees. You can do these problems in radians or degrees, but every problem that I give you, it's going to be in degrees. So put it in degrees and keep it in degrees. At least for 4.1 part 2. We did radians earlier in the week, but we're not going to do anything with radians today. So 2 tan 40 is about 1.68. So we'll just say 1.68. Okay. Now, I have 2 out of 3 of the sides. What could I do to get the third side? You could do Pythagorean Theorem, but why do you think I'm going to suggest you stay away from that?
Because you rounded A.
All right, so A is rounded, that's not exact. And even worse, it could be wrong. What if A is supposed to be 3.7 and you put 1.6? It's not even close. So if A is wrong and you use it, then C is wrong. So we've got A, we're done with A. We're not going to use it again for the rest of the problem. So let's find C. Basically the same way we found A. So what I'm going to do visually again is just circle what I was given. Just use a different color. 2, 40. And this time you want to find C. So just focus on what's circled in green. The 2 sides that we're involving this time are adjacent. We're using adjacent every time. And now hypotenuse. So what trig function has adjacent and hypotenuse in it?
Cosine.
Cosine. Yep. So now we're going to use cosine to find C. So find C. So it's going to be the cosine of, what's my angle that I'm using? 40. Yep. Stay away from the 50. We're not using that. You could, but just don't. Right. So cosine of 40 equals And now cosine is adjacent over hypotenuse. So Sam, when I write that out, what's adjacent over hypotenuse? Yep, 2 over c. Bless you. Now, this one is a little bit different. It's similar, but instead of the variable in the top, now the variable's in the bottom. So, in order to get the variable by itself here, first thing I want to do is just at least get rid of this fraction. So Sheridan, what could I do on both sides so I wouldn't have a fraction here anymore? Multiply by what?
2.
If you multiply by 2, that would just become a 4, and that would be a 2. Yeah, let's multiply both sides by c. Keep in mind, though, this is what you had originally. Because I'm going to come back to that in a second, and you'll see something. So now the c's are gone, and you have c times the cosine of 40, which is, it's some decimal, I don't care what it is right now, equals 2. Now, how would you get c by itself? There we go. Yep, what would you divide by?
C.
Well, if you divide by c, you're going to put it right back the way it was. Then you're just going to have cosine 40 equals 2 divided by c. Like, what if it was x times 5 equals 10? How are you going to get x by itself there? Times, that's a times 5. What by 5?
Divide.
Yep, you divide both sides by 5 and you get x equals 2. So what would you divide both sides by here? Well, did you divide both sides by 10 here?
No.
No, so you're not going to divide both sides by that number that's over there. Henry?
You divide by cosine of 40.
You're dividing by the number that's right next to your variable. So if you divide by that number, you're going to divide by whatever that number is, cosine 40. So divide by cosine 40. Divide by cosine 40. That's gone. And look at what you just got. So look at what you started with.
Could I have your attention, please? At this time, all
All right. So let's look at what we got. So we got c by itself. Look at what, we'll just call this box 1 and box 2. We're going to be able to jump right from box 1 to box 2 from now on. What basically ends up happening to get from box 1 to box 2? Like if you just wanted to describe one thing you could do without going through all these steps in the middle. Well, if you divide by 2, you'd have this. You'd have 1 over c equals cosine 40 divided by 2. It's more of a visual thing that happens. Yeah.
Just like the 2 over.
Can you explain more?
Do that's on top of the c. Put it on top of the cosine 40. Do you slide it over? C over the cosine.
Okay, yeah, so, yeah, basically what happens is you just switch these two. Right? So anytime you have a fraction like this, let's say you had 3 equals 4 over x, and you want to solve for x, just switch those two. X equals 4 over 3. Right? That always works when you have 3 things like that. If you don't like that trick, then don't use it. Just go through these steps every time. Multiply both sides by the variable, and then divide by cosine 40. Okay? But I'm going to use this trick from now on of just switching what's in the bottom and what's on the other side. Okay. Now we need to type that in. 2 divided by cosine 40. 2.61. And that's how you solve a triangle. We're done.
So when you multiply like c times cosine of 40, is that always going to be like what you use to cancel out in the fraction of that makes sense?
So what cancels out in the fraction is always going to be what's right next to the letter.
No, like up in box 1,
Box
like how
one.
you multiply by c, is it always going to be whatever number you multiply by to cancel out, that's what you multiply cosine or whatever?
Yeah, whatever's in the bottom here is what you're going to multiply cosine by.
Okay.
If you want to do it that way. I'm not going to do it that way from now on. I'm going to use this trick of just switching these two to get c by itself. Because it saves me one step in the middle. Doesn't save a lot. It saves that one step. Okay. And there's your answers. Now, what could you do with these to kind of check if they're right? I didn't want you to do it to get the answer, but we can use it to double check if we got them right. Yeah, we can check with Pythagorean Theorem and see, does 1.68 squared plus 2 squared, does that equal 2.61 squared? If it does, then you just checked your answer with Pythagorean Theorem, and it's probably right. Okay, mine didn't come out the same. So does that mean I did something wrong? Tyler, what do you think? Yeah, rounded. I mean, it's close, right? 6.82, 6.81. So using Pythagorean Theorem to check this, it does check, right? Which means you did it right. You might not always have time to check your answer on the test like that with Pythagorean Theorem. So if all you have time for is just do the find A and do the find C part. And don't check it. Okay, let's try one more of the type where I'm starting you off with a side and an angle. And then we'll do the type where I start you off with two sides, okay, which is a little different. We'll try one or two of those, and then we'll finish up with a word problem. All right, so I'm going to let you guys try and find B and C together, but let's knock out alpha quickly together.
70.
Alpha would be 70. Now, should you use that to find B?
No.
Should you use it to find C? No. Stay away from the alpha. Okay. Use beta to find B and C. All right. So make your diagram, and then label everything opposite, adjacent, and hypotenuse. And that'll help you figure out which trig functions you're going to use. You're going to always use two in a problem like this. Either sine and cosine, or sine and tangent, or cosine and tangent, but you've got to use two. One to get B, one to get C. Okay, so in order to help you figure out which trig function you should use, you should take that information and do what? Yeah, make a diagram. Okay, so let's draw out what we've got. Again, it doesn't matter how you draw your triangle. A across from alpha, B across from beta. That's all you have to make sure you do. So if I put A here, that means alpha. A here, alpha there. If I put B on the bottom, beta would go on the top. And where do we always put C? Hypotenuse. Now, when I went around, some people put C in a different spot. I mean, you're going to get confused if you do that. Technically, if you want to use the letters, like I said, X, Y, Z, you can for the sides. But it's going to confuse you. All right, so we already found alpha, making sure all the angles add up to 180. Now, whether you find B or C next, it doesn't matter. Okay. What I like to do, and this is up to you, circle the two things that you're using to make sure you remember to use them. Why am I using the 20 and not the 70? Because we found the 70, so what's wrong with stuff that we find? Could be wrong. All right, so that's the two things I'm going to be focused on using. Now I'm going to circle the thing that I want to try to find this time. Okay. I want to find B. All right. What's the next thing I should do with those three sides? This is the last step, and that'll help me to figure out whether I use sine, cosine, or tangent. Label them. Yeah, label them with the words opposite, adjacent, and hypotenuse. So Jay, what's B? Opposite. And Sam, what about 6? Yep, adjacent. And C, it's the one label you should never really have to think about. It's always your hypotenuse. Okay, so let's look at how to find B. So, Johanna, what are the two sides that we're going to use to find B?
Did my triangle different? I don't know. I did opposite over adjacent for mine.
You're still going to use opposite and adjacent, and we're going to do the same thing, right? Even if you draw it differently, as long as she set it up where 20 was across from B and 6 was across from alpha, her triangle is still going to work just as good as ours is going to work. So it is opposite and adjacent. And what trig function did you use?
Tangent.
Tangent, that's correct. So, tangent of your angle equals opposite over adjacent, B over 6. Even though your diagram was different, is that the same equation you had? Yep, it'll always be the same. Okay. And, Jamin, how do I get B by itself there? Yep. This is the one where you don't switch anything, you just multiply by 6. And that's your answer for B. So let's type it in. 6 tangent, 20 degrees. Make sure you're still in radians. My calculator should stay in degrees. Sorry, make sure you're in degrees. If it goes back to radians, fix it. 6 tan 20. Okay, 2.18. Okay, and are we going to use Pythagorean Theorem to get C? No, why not? Right, because B could be wrong, and we don't want to use something that's wrong. So let's find C. All right. So to find C, now we're focusing on adjacent and hypotenuse. Don't use B, because we don't want to deal with B. So Nick, which trig function has adjacent and hypotenuse in it?
Cosine.
Cosine, good. So we're going to do cosine. Always cosine of your angle. Adjacent is 6. Hypotenuse is C. Now, what's the trick you can use there to get C by itself? If you don't want to go through the arithmetic stuff. Yep.
Switch cosine and C.
Yep. Just switch those two. So you're going to get 6 divided by cosine 20. Type that in, see what we get, and then that's it. 6 divided by cosine 20. 6.39. Now, one thing you can do to quickly check your answer, if you don't have enough time to go through the Pythagorean theorem to double check it, make sure the biggest side is C. So the biggest side is always with the biggest angle, and the smallest side should be with the smallest angle. And that did happen here. Another thing that always happens in triangles is if you add any two sides together, it's always bigger than the third. It has to be, or you don't have a triangle. So if you add A and B, you get 8.1. Yep, that's bigger than C. If you add B and C, that's bigger than A. And if you add C and A, that's 12 something. That's bigger than B. Right, so there's a couple things you can do quickly to double check your answer. Okay, any questions on that? Okay, so the last type. This is where they give you two sides. So what can't you do here right away that you could do in the last problem, or last two problems? Yeah, you can't use the angles to get the third angle because you're missing two of them. But now there's something else you can do that I'm okay with you doing, but I wasn't okay with you doing it before. What am I okay with you using this time, you think? Yeah? Yeah, why am I okay with Pythagorean theorem now? Yep, you're going to use it to find C, but why am I saying it's okay to use it?
You didn't figure out that A.
Right. These were given, so you're not using anything you found to do C. So we're going to plug them in to Pythagorean theorem and get C. So A squared plus B squared equals C squared. 13 equals C squared. And Michael, how do we get rid of the exponent of 2? Take the square root. Pretty much every problem that you do that's like this, where you're solving for the sides, you're going to round that off. I know in last night's homework we didn't. But in last night's homework, we weren't actually solving for the sides. We were just writing sine, cosine, tangent, cosecant, secant, cotangent. That was a little different. So in this, go ahead and just round it off. So it's about 3.61. Okay. Now let's draw the picture and label just what was given. I'm going to put A there, which actually I know A is 3. And Colby, if I put A there, what angle is going to go across from that?
Across from A would be your alpha.
Yep. A goes across from alpha. B goes across from beta. And that's C. I know it doesn't look like a right triangle because I didn't draw it very well. But again, nothing here is to scale, so it's fine. Okay. So I'm going to do what I always do. Circle the two things that I was given. And now I'm going to pick one of the two things I don't know to find. Sheridan, do you want to do alpha first or beta?
Beta.
Beta? Okay. So we're going to do beta. So, Ariel, can you label all three sides for me? Which one is which? So we're looking for it from the perspective of beta. So they're
Opposite.
Yeah.
2 would be opposite, 3 would be adjacent, and 2 would be hypotenuse.
Yeah. Remember, that's from the perspective of beta. If you switch your perspective, you have to make sure you switch your names of your sides. But we are finding beta, so that is correct to find beta. So, from beta, we're going to use opposite, and we're going to use adjacent, because those are the two things we know. Sarah, what trig function has opposite and adjacent? Yep, tangent. So let's set up our equation. Tangent of, always put in your angle, which this time we don't know. Tangent of beta equals 2/3, opposite over adjacent. Now, the goal is to get beta by itself. Tangent is a function. It's like if I gave you this, and I said get x by itself. Squaring something is a function. It's not like add, subtract, multiply, or divide. Squaring is different than all of those. So the only way to get rid of squaring is with another function that cancels out squaring, and that's square rooting. So we've got to do the same thing here. We need to cancel out tangent. What would be the function that we could use that would cancel out tangent? Yep. Inverse tangent. That's what we learned on Monday, Tuesday. So now we're going to take inverse tangent on both sides. Some people say multiply both sides by inverse tangent. No, you're not multiplying. Any more than if I gave you x squared equals 16 and you said, oh, multiply both sides by the square root like this. No. That's just taking the square root of both sides. So just say take the square root of both sides. Just say take the inverse tangent of both sides. There's no multiplication there at all. And same thing here. You're going to take 2/3 and you're going to plug it into the inverse tangent function. That's gone. So now, beta equals, and we're going to type inverse tangent of 2/3 and see what we get. So second, inverse tangent, 2/3. So it's 33.69, and I need a label on that. What would be my label?
Degrees.
Yeah, degrees. Only because my calculator is in degrees. And they gave you other information that was also in degrees. So just stick with degrees. Now, if I was running out of time on the test, what could I quickly do to get beta and just hope that I got alpha right with it?
Take 33.69 from 90.
Yep. So when we do beta, it should come out to minus 33.69. Not that. 90 minus 33.69. So it should be 56.31. But if you do it that way, you're assuming you got alpha right. And if you didn't, now you just got beta wrong as well. So I'm going to finish it up and find beta exactly the same way we found alpha. All right, so we got that. So this was to find beta. And this is going to be to find alpha. So I'm going to circle what we're using. You want to use the 3. It was given. Use the 2 because it was given. And this time, use the alpha because that's what you want to find. Now, these names don't apply anymore. Hypotenuse does. Because hypotenuse is always across from the 90. But you're finding another angle, so it's like you just walked to a different part of the triangle. It's like you turned your direction. So now, the side that's 3 is your what? That's your opposite. And the side that's 2? Adjacent. You're still using opposite over adjacent, though. It's the same 2 sides, it's just they switched, the names switched. So we're going to be using tangent again. So, tangent alpha equals, and Michael, what's opposite now?
3.
In adjacent?
Yep.
So it's going to be 3 over 2. They just switched. Right. And to get alpha by itself, what function do I need to use? Yep, inverse tangent. So take the inverse tangent of both sides. Now, the way I did this, I'm actually double checking my answer right now. I already know what I think it should be. It should be 56.31. If what I do this way comes out to 56.31, then I would have gotten the same answer 2 different ways, which means it's got to be right. So let's do second inverse tangent of 3 over 2. And it is 56.31. Okay, so that's how you solve the second type of problem. That's starting you with 2 sides. So the only time you ever have to use inverse trig with what we're doing is in this case right here. If you get 2 sides, you have to use inverse trig. If you have the first case, nope, you're never going to use inverse trig for that. All right, so last question. Okay, it says you lean a 20-foot ladder against the house. The angle between the ladder and the house is 17 degrees. I want to know how high the ladder will reach. Not necessarily how high you could reach, because you're standing on the ladder. You can usually reach a little higher than the top of the ladder. I basically just want to know where the top of the ladder is going to be. That's what I want to know. All right. So in this problem, what we've been doing so far for every problem is the same thing we want to do with this one. And in general, we want to do this with any word problem. What do you want to do with all that information? Yeah, we want to make a diagram. Yep. Yeah.
How would you determine if C or 17 is alpha or beta?
So we're not going to know whether it's alpha or beta. You could call it whatever you want. Okay. Let's draw the picture and see what happens. So somebody tell me what's in this picture, like physically. What's in the picture?
20 feet.
20 feet. That'll be a label of something in the picture. A house and a ladder. And what else do you need besides a house and a ladder? You need ground. So here's the ground. Here's your house. And you have a ladder leaning against the house like that. Okay. What do we know about the ladder? We know 2 things about it.
40 feet.
It's 20 feet. So when they say 20 feet, they mean that. So that's 20. And what else do we know? So where is that in the picture? The angle between the house and the ladder. Inside the triangle, at the bottom of the triangle or the top? Well, angle at the bottom, that's the angle between the ground and the ladder. Because the black line is the ground. It's the top. This is the house. That's the ladder. So the angle between the two is right there. All right, so what I'm going to do is I'm just going to take this picture. What I drew in green, that's the important part of the picture. This side's 20, and the angle at the top is 17. Find how high the ladder will reach. What side of the triangle do they want you to figure out? Yep.
The adjacent side, so it's the side that would be like the side of.
Yeah, the adjacent side right there. So I'm just going to call it X. You can call it A, you can call it B, but you don't know what alpha or beta is. They didn't tell you labels. So we're not going to use those labels. We're going to use the labels opposite, adjacent, and hypotenuse. All right, using that to find that. So what's the 20? It's your what? Yep. And what's the X? I think Johanna already said that. It's the what?
The adjacent.
Yep, it's the adjacent. So you know the hypotenuse, you want the adjacent. which trig function out of sine, cosine, and tangent has those two? Cosine. Can you set that up for me, Colby? Cosine of what?
You do x over 20.
I gotta fill this in first. That's my argument.
The cosine of 17.
So we're gonna take the cosine of 17 degrees, and what's that equal to?
X over 20.
Yep. And last step, multiply both sides by 20. And that is how high the ladder will reach. So the ladder's 20 feet. You're going to put it at a little bit of an angle. Maybe it'll reach like 19 something feet. Because the more of an angle you put on it, the lower it's going to reach. And beyond a certain point, the ladder would just fall. 20 cosine 17 gives you 19.13 feet. Okay, so the word problem is always going to involve somehow you're going to have a triangle in it, and it'll be a right triangle. Now, you could have said, how do you know the building is perpendicular to the ground? How do you know the building was built straight? Well, in order to do what we're doing this week, we have to do that. If it was leaning, then this problem gets a lot more complicated. Like if you had the Leaning Tower of Pisa, leaning like that, and you said you're going to put a ladder against that. The problem is this triangle in red, it's not a right triangle anymore. Now we can't do it the way I taught you. We'd have to do something else. Okay, but for this week, we're just going to assume that you got that right triangle. All right. So this will be the homework for tonight. So 31 to 39 odd, 43 and 47, and 51 to 55 odd. So plan for tomorrow, we'll go over that, probably within the first 15 minutes or so. Then after that, I'll give you guys some review problems for maybe like 30 minutes. Walk around, I'll answer any questions. And then probably the last 30 minutes of class, I'll give you part 1 of the test. We'll do part 2 of the test. Come in right away. When you come in, we'll start part 2 on Friday.